An electric charge denoted by Q is an intrinsic property of the fundamental particles that make up matter, which causes the matter to experience a force when placed in an electromagnetic field. Subatomic particles, protons, and electrons carry the electric charge. The figure shows subatomic particles, proton, and electron which carry charge, lightning which is caused by electrostatic discharge, and the electromagnetic field. There are two types of electric charge: positive charge, plus, and negative charge, minus. Subatomic particles, protons, plus, are positively charged. Subatomic particles, electrons, minus, are negatively charged. If there are more protons than electrons in a matter, it is positively charged. If there are more electrons than protons in a matter, it is negatively charged. If there are an equal number of protons and electrons in a matter, as it usually is, it is electrically neutral or simply neutral. The figures show subatomic particles, positively charged proton, and negatively charged electron. If the number of protons is greater than the number of electrons, we get a net positive charge. If the number of protons is less than the number of electrons, we get a net negative charge. If the number of protons is equal to the number of electrons, we get a neutral material. Like charges repel each other, that is, positive charges repel each other, move away from each other, negative charges repel each other, move away from each other. Unlike charges attract each other, that is, positive and negative charges attract each other, move towards each other. The figure shows that like charges repel each other and move away from each other, two positive charges repel each other, two negative charges repel each other. The adjacent figure shows that unlike charges attract each other and move towards each other, a positive and a negative charge attract each other. We can classify matter according to its ability to allow charge flow through it as conductors, semiconductors, insulators, and superconductors. Conductors are materials through which charges can move very freely, for example, metals like copper, the human body, tap water, etc. Insulators are materials through which charges cannot move freely, example, plastic, rubber, glass, pure water, etc. Semiconductors are materials that allow the flow of charge better than insulators but worse than conductors, example silicon, and germanium used in computers and other electronic chips. Superconductors are materials that allow the flow of charge without any hindrance. Coulomb's law works only for charged particles, or materials that can be treated as charged particles. If two charged particles, with charges Q1 and Q2, are brought near each other, they exert an electrostatic force on each other, given by the equation vector F equal to K times Q1 Q2 by R squared times unit vector R cap, where vector F is the electrostatic force, Q1 and Q2 are the charges of the two charged particles, R is the distance between the two particles, K is a constant called the electrostatic constant, or Coulomb constant, and R cap is the unit vector. The figure shows two positive charged particles with charges Q1 and Q2, separated by a distance of R, from the center of one to the center of the other charged particle. The electromagnetic force on Q2 due to Q1 is vector F, directed away from Q1 along the line joining the centers of the two charged particles. The SI unit of electric charge is Coulomb, C, since the rate of flow of charge is current, I equal to dQ by dt, the unit of current is ampere, A, and the unit of time is second, S, so, ampere, A, equal to Coulomb, C, by second, S, or, C equal to A times S. The electrostatic constant is given by K equal to 1 by 4 pi epsilon naught equal to 8.99 into 10 raised to 9 Newton meter square by Coulomb square, where epsilon naught is the permittivity constant. Epsilon naught equal to 8.85 into 10 raised to minus 12 Coulomb square by Newton meter square. If both particles are positive, or both are negative, the force vector is away from each other. If they are different, the force vector is towards each other. Electric charge is not continuous but discrete, made up of multiples of an elementary charge. Any positive or negative charge can be written as Q equal to NE, where N equal to plus or minus 1, plus or minus 2, plus or minus 3, and so on, and E is the elementary charge. E equal to 1.602 into 10 raised to minus 19 coulombs, even though quarks, which are constituent particles of protons and neutrons, have charges plus or minus E by 3, or plus or minus 2E by 3, they are not taken as elementary charges, because they cannot be detected individually, and for historical reasons. Since electric charge can have only discrete values, it is quantized, so, an electric charge can be plus 25 E or minus 45e, or any integer multiple of e, but never a non-integer multiple of e, like say, 2.5e. Electric charge is conserved, that is, the total electric charge in an isolated system never changes. The amount of positive charge, minus the amount of negative charge, does not change or is conserved. An example of conservation of charge is the radioactive decay of uranium-238 nucleus into thorium-234 nucleus by emitting an alpha particle. U-238 gives thorium-234 plus alpha particle. Uranium-238 contains 92 protons or a charge of plus 92e. Thorium-234 contains 90 protons or a charge of plus 90e, and alpha particle contains 2 protons or a charge of plus 2e, so electric charge is conserved. Charge before decay, uranium-238, plus 92e, equal to charge after decay, thorium-234, plus 90e, plus alpha particle, plus 2e.